Hello, this is Gangadhar from Maths Ganga. Now I am going to discuss some more problems related to LHL and RHL. In the previous two videos of calculus, we discussed the definition of limit as well as the definition of a left hand limit and right hand limit. Now I have a graph on the board. See, the graph of the function f of x is given like this. This is the graph, and now I am going to find out the limit values of the f of x at x is equals to 2, at x is equals to 3, at x is equals to 4, as well as at x is equals to 5. I need to find these values. Now see, first of all, to find limit x tends to 2 f of x. At 2, as per the definition of left hand limit and right hand limit, if you observe in the surroundings of 2, if we move towards 2 from the left side, the function is not defined, and as you move from the right side towards 2, the function is defined and the function is approaching 2 also towards 2. That in the sense, in the left side of 2, the function is not defined, the function itself is not defined, so there is no matter of limit. So in the left side of 2 there is no limit, but in the right side of 2 the limit value is 2. So limit x tends to 2 f of x is directly equals to limit x tends to 2 plus. One side limit is not defined, and the other side limit is the only limit. Actually what we discussed it is, if both left hand limit and right hand limit are equal, then only we say the limit of f of x at that particular point. But for coming to the point 2, since the left hand limit is not defined, as the function is not there in the left side of 2, the right hand limit is directly equal to the limit value of f of x at that particular point. So limit x tends to 2 f of x is nothing but limit x tends to 2 plus f of x, and that value is 2 itself. Now coming to limit x tends to 3 f of x. Now if you observe in the surroundings of 3, see, if you concentrate in the surroundings of 3, as you move towards 3 from left side or as you move towards 3 from the right side, in both the cases the function is in this region. For the values which are less than 3, the functional value is 2. For the values which are more than 3, again the functional value is 2. So for the left side region as well as the right side region, the functional values are in the region of 2. So both left hand limit exists and it is 2. Right hand limit also exists and it is 2. So the limit x tends to 3 f of x is directly equals to 2. Here both LHL and RHL exist. But whereas coming to limit x tends to 4 f of x, if you look here for 4, see, the left hand limit exists here, because if we change the values of x in the left side region of 4, if x is running towards 4 from the left side, then the functional value is also existed too. But if in the right side region of 4, if the values of x are changing and running towards 4 from the right side, then here the function is not defined. Since the function is not defined in the right side region, the left limit directly considered as the limit. So limit x tends to 4 f of x is directly equals to limit x tends to 4 minus f of x, and that limit x tends to 4 minus f of x value is directly 2. Here the graph is a constant graph at 2 and somewhere it's breaking, so always we found that limit as 2 only. Now coming to the point 5, we need to find out the limit value of the given function f of x is equals to 5. If you observe in the surroundings of 5, see, the function is not defined in the left side region of 5, the function is not defined in the right side region of 5. So left hand limit is not defined, right hand limit is not defined, so limit is not defined, but the functional value is defined as 2. F of 5 is 2, but left hand limit, right hand limit both are not defined, so limit x tends to 5 f of x not exist. So for this function, if you observe, the limit value at x is equal to 3 is 2, which is equals to both LHL and RHL. At x is equals to 2, left hand limit not exists, right hand limit is directly equal to the limit. At x is equals to 4, right hand limit not exists, the left hand limit is directly equals to 4. But at 5, both left and right not exist, so limit not exist. Right? This is the first problem for today's discussion. Now I am going to discuss some more. Right? I am clearing this. So next problem what I am going to discuss is this one. Limit x tends to 0, 1 by x. What you say about the 1 by x value as x tending to 0? See, limit x tends to 0, 1 by x. Studying limit x tends to 0, 1 by x is nothing but we need to observe both left hand limit as well as the right hand limit. Left hand limit is nothing but limit x tends to 0 minus 1 by x, whereas the right hand limit x tends to 0 plus 1 by x. So, to find out the left hand limit as well as right hand limit for 1 by x, now I am observing the graph. Okay, for a see what is the graph of 1 by x. If this is 0, okay, if you observe the graph of 1 by x, at x is equals to 1, the functional value is 1. At x is equals to minus 1, the functional value is minus 1. It is moving through this point and the graph will be like this. This is the graph of 1 by x actually. Right? Since this is the graph of 1 by x, this is point 0, we are going to find out the limit at 0. See, if x values are moving towards 0 from left side, the graph is going towards minus infinity. And as x values are moving towards 0 from right side, the graph is going towards infinity. So, this graph directly suggesting that the right hand limit value is plus infinity, whereas the left hand limit value is minus infinity. So, for the function limit x tends to 0, 1 by x, both left hand limit and right hand limit are different. One is minus infinity and the other is plus infinity. So, this is very clear from the graph. Right? Then, I am going to discuss one more problem. Third one, limit x tends to 0 log x. What you say about the value limit x tends to 0 log x to the base some e. See, actually, limit x tends to 0 log x. It is very clear that finding the limit value is nothing but concentrating on the left hand limit as well as the right hand limit. Concentrating on right hand limit is nothing but x tends to 0 plus, whereas concentrating on the left hand limit is nothing but x tends to 0 minus. Since x tends to 0 plus, here x greater than 0, and whereas here x less than 0. It is very clear that for the negative values of x, now x is not defined. That in the sense, in the left side region of 0, if x is less than 0, the function is not defined. So the left hand limit also not defined. And as a case, if you observe the graph of log x, how is the graph of log x? The domain of the log x is only positive values of x. So the graph exists in the positive region, and for 1 the value is 0, and for e the value is 1 if this is e, and the graph is like this. This is the rough sketch of log x. Now if you observe, if you move the value of x towards 0 from the left side, the graph is not defined. Whereas if you move the values of x towards 0 from the right side, the graph is moving towards minus infinity. So, the right hand limit exists and the right hand limit value is minus infinity, whereas the left hand limit is not defined. Since left hand limit is not defined, right hand limit value is minus infinity, we have to consider that log x tends to 0, log x to the base e as minus infinity, very clear from the graph. Right? Then I am going to deal some more functions which may differ left hand limit and right hand limit. See, now the fourth thing what we are going to discuss is limit x tends to 3 step x. See, we are very familiar with the greatest integer function, that is step x. See, this dealing with step x is again nothing but finding left hand limit as well as right hand limit. And the left hand limit is nothing but as x tends to 3 minus, whereas the right hand limit is x tends to 3 plus. Since x is running towards 3 from the left side, the value of x is less than 3, and since x is running towards 3 from the right side, here the value of x is greater than 3. Since the value of x is less than 3, here the step value will be 2, whereas here the step value will be 3. Since x is more than 3, its step value is 3. Since here x is less than 3, its step value is 2. So, the left hand limit is directly equals to 2, whereas the right hand limit is equals to 3. So, left hand limit and right hand limit both are different. So, limit x tends to 3 step x not exist because both are not different. See, both are different. If both are equal, then only we say that limit exists. Since they are different, Usually we say that limit x tends to 3 step x not exist, but limit x tends to 3 minus step x exist, whereas limit x tends to 3 plus step x also exist, right? See, if you observe the graph of step x for the values of 0, 1, 2, 3, 4 like this, for all the values in between 0 and 1, the result is also 0. So the graph will be like this. And for all the values between 1 and 2, the step value is 1, so the graph will be like this. And for all the values between 2 and 3, the result is also 2, so the graph is like this. And from 3 to 4, the graph will be like this at 3. Okay, see, if x is running towards 3 from the left side, so that means in this region we need to identify. In this region, the result is 2. And in the right side region of 3, the result is 3. So left limit is 2, right limit is 3. Okay, it is clearly suggesting that limit x tends to 3 step x not exist. In the same way, at every integer, the limit for step x not exist. That in the sense, left limit and right limit are different. But if you take something like some 1.4, if you take some 1.4, in the region of 1.4, if you observe, the left limit is 1, whereas the right limit is also 1. That in the sense, at this particular point 1.4, the limit exists. That means if you observe carefully, for the step x, limit value not exist at integral values and it exists for non-integral values. Okay, so this is limit x tends to 3 step x. In the same way, next thing I am going to discuss, the fifth one, is limit x tends to some 4 fractional part of x. What you say about the fractional part of x? See, for the same thing, if you observe the graph of fractional part of x, I think you are all very familiar with the properties of fractional part of x. Fractional part of x is nothing but it results as this fractional part of the given function, right? Given value, right? For example, if it is 2.3, then its fractional value is 0.3. If it is 2.9, the fractional value is 0.9. That in the sense, the fractional value, fractional part of x, always these values are in between 0 and 1. The range of fractional part of x is always between 0 and 1. For the integer, that in the sense, fractional part of 4 is 0. Fractional part of 5 is 0. Fractional part of 4.2 is 0.2. See, if you observe the graph of fractional part of x, if you take the values in between 0 and 1, for 0, the fractional value is 0. For 0.1, the fractional value is 0.1. For 0.2, the fractional value is 0.2. For 0.9, the fractional value is 0.9. So the graph will be like this, from 0 to 1. And from 1 to 2 also, at 1 the fractional part is 0 and the graph will be like this. In between 2 and 3 also, the graph of fractional part is like this. So in between 3 and 4, in between 4 and 5, everywhere the graph is in the same way, like this. So now I am going to check limit value at x is equals to 4. So you need to concentrate in the surroundings of 4. If you concentrate in the surroundings of 4, see, the graph will be like this actually. For 3.9 it is 3.9, so the graph will be like this. So if you concentrate in the left side region of 4, the function, the graph is running towards this open circle. That means it is running towards 1. Whereas if x values are more than 1, the graph is running towards 0. See, if you observe carefully, for the limit, left hand limit and right hand limit, if you observe, for left hand limit, the value of x is less than 4. For suppose if you treat it as like 3.9, the result is 0.9. If you treat it as 3.999, the result is 0.999. That means if x is approaching towards 4 from the left side, the left hand limit is approaching to 1 as in the case of graph. Whereas the right hand limit value is 0. So for the function, limit x tends to 4 fractional part of x, the left limit value is 1, whereas the right limit value is 0. Both are different. So limit at 4 for fractional part of x also not exist. So these are the different problems which give us a confident idea related to the left hand limit as well as the right hand limit. Right? Now I will give you one more thing. For example, sixth one. limit x tends to 0 mod x by x. See, to discuss its limit value, again we need to concentrate on left hand limit and right hand limit. For left hand limit, x tends to 0 minus. For right hand limit, x tends to 0 plus. Since x is tending towards 0 from left side, x less than 0, and then mod x value is minus x here. And here x greater than 0 and mod x value is plus x here. Since for the left hand limit mod x is minus x, it is very clear that for left hand limit the value is minus x by x, and for right hand limit the value is x by x. Here it is minus 1, here it is 1. So for the function limit x tends to 0 mod x by x, if you try to find the limit value, the left hand limit value is minus 1, whereas the right hand limit value is 1. Again, for this function at 0, the limit does not exist. So at other point, the limit exists. Right? So we are able to discuss the same thing with the graph also. But now here it is algebraically. Right? I will give you one more function, that is limit x tends to 0 e power minus 1 by x. Seventh one. Limit x tends to 0 e power minus 1 by x. What is its left hand limit and right hand limit? And check if they are equal, whether the limit exists or not. Right? See, just write limit x tends to 0 e power minus 1 by x. Okay? And then comment the answer in the comment section. The left hand limit value and the right hand limit value, and about the limit of this e power minus 1 by x, x is equals to 0 in the comment section. Right? Thank you.